I believe systems that are in multifamily can range from 150 kilowatts on up to 900 is one of the largest multifamily housing projects in California. Can one of you just verify that?
Oh, and thank you, Bernadette. Martin from Sunlight Power. And just to verify, so multifamily housing has a lot of different factors and a lot of different scales, and some of the projects that we've worked on have been in the range of very small, 10 kilowatts on individual units or common area loads, but also very large as far as 900 units, and established that has a lot of capacity if you're trying to add battery storage and also photovoltaic systems to that. The key is that within that sector, there is replicable features that are very similar to a standard residential installation. So it's the scale of that size is not outside the realm of capacity for a modularized, simple plug-and-play installation on a unit-by-unit basis. So I think our as far as where to draw the line from a residential versus commercial, I think a lot of us are saying, well, drawing the line at residential for commercial is not a great place to draw the line, but if the line is already drawn, we need to say, like, the residential side has a fully capable team that will supply the constituents and the consumers with what they're asking for, and that's where the industry is from a lot of who they call the solar contractor that is also doing the work for battery storage. It's a paired. That's how it works on a lot of these residential and multifamily housing. We're the ones that are leading the charge on this and supplying with them with the resiliency that they want. And it's not something that we see a lot of other electricians really being that interested in. So thanks.
Okay.
Yeah, I can speak to a little bit of multifamily. Some of the multifamilies we've done in California recently via the solar home or new home mandate have been relatively small systems since they're apartment loads. Typically, their main service panels are in the 70 amp or lower per unit. So these systems are typically a 2 kW PV system paired with one 10 kilowatt hour battery. And that's enough to usually run that apartment 24 hours in the event of an outage. So that system would be perfect for a 3-story multi-level unit house that has enough, or apartment building that has enough roof area to supply that PV. All those batteries would be co-located probably in an energy storage room or a battery room or an electrical room. And that electrical room, per the building code, would have fire resistance rating.
Yeah, I would just like to interject, though. Bernadette opened up, and I'd like to go to the C10 industry if I could. I mean, and then we can go ahead and have more discussion. So, Eddie, who are you going to present?
Thank you, David. And let me just begin by saying, from the start, this has been about an elevated level of safety for the installers and the end consumer based on the installing individual having a background in electrical theory and being state certified. And as this technology has developed and increased in usage, that there's a need to protect the consumers of the state of California. Today we have 2 electrical engineers here to present on the safety aspect. I know that's been a big part of this debate, and so we're going to have them do that. And after that, we will follow up with some comments from our side regarding the limits and what they are based on code, and where the electrical industry and the National Fire Protection Association lays out delineations on if there's a necessity to ensure that there is a level of competence on the installations. So with that, I'll turn it over to Cliff and Marco.
My name is Cliff Ishii. As I mentioned before, I'm a licensed electrical engineer. I had a wonderful bio printed up really nicely, multicolored, but apparently it's lost in limbo right now. Allow me to introduce myself. I'm past president of the California Society of Professional Engineers. I'm a past regional president of the National Society of Professional Engineers. I'm a fellow in the National Society of Professional Engineers. I have been involved with the California licensing Board for Professional Engineers and Land Surveyors. I was chair of the Electrical TAC Committee, Technical Advisory Committee. Then prior to them running out of money, then my position ran out of position. So this is back 15 years ago. What I bring to the table here is experience in over 10,000 projects in my lifetime. I will die when I hit number 15,000, so I'm not going to hit that one. I'm very proud of my profession. I'd like to introduce the codes, which I'd like to kind of bring to the table here, are a set of minimums. And you can't get involved with this subject without a minimal understanding of the codes. Now, the codes are written by code writers, and I guess that's what provides a job for us engineers, is that we can read the codese and translate it into real projects. As a licensed engineer in the state of California, I'm licensed to protect everybody, not just the people who hire me to do their jobs. I take my job very seriously, and that's why I've taken the time to appear before you. One of the things that is probably the least understood part of the code, and I have to admit, even to myself, didn't worry about it, the functionality, knew how to take care of it, but I don't install, and I always trust that there's a qualified installer. It's in section 250.6, Objectionable Current. That sounds pretty innocuous. This probably hasn't been brought to the table today. And the reason I talk about this is the system that we're talking about, battery storage, connected to an inverter, sometimes connected to PV, eventually connects to a real system that's, in many cases, already there. We've already heard about the numerous examples of you run the conduit on the outside of an existing building. You don't have to worry about fire safety and stuff like that. But you ultimately can connect to an existing panel of whose condition could be a 1950 panel, whose manufacturer went out of business, or it could be a modern day panel that says solar ready on it. The arrangement to prevent objectionable current is the grounding of electrical systems, circuit conductors, surge arresters, surge protected devices, and conductive, normally non-current carrying metal parts of equipment shall be installed and arranged in a manner that will prevent objectionable current. Okay, sounds safe enough. We will have a presentation of what happens when you have objectionable current. This is, I'm quoting Mike Holt, for those in the industry will know who he is. Preventing objectionable current to prevent a fire, electric shock, or improper operation of circuit overcurrent protection devices or electronic equipment, electrical systems, and equipment must be installed in a manner that prevents objectionable neutral current from flowing on metal parts. So now a little more elimination here. We don't want fire. We don't want electric shock. Electric shock sometimes kills people. And will prevent the improper operation of overcurrent protection. Circuit breakers. A lot of us put our faith in the circuit breaker is going to blow before something bad happens. If you have objectionable currents, that circuit breaker may not turn the power off. And it's all contingent on the existing system and the existing breakers there and the state of the wiring, stuff like that is very important. Grounding, which is germane to what I'm talking about, and again, quoting Mike Holt, no other article can match Article 250, which is grounding, for misapplication, violation, and misinterpretation. Again, the need for people who understand electricity, people who have been trained to understand this, people who have had experience with electricity. I'm one of those electrical engineers that probably, when I got shocked by playing with my record player before, we had the modern day music machines. And I'd put the plug in there, I'd get a little shock, and it didn't really bother me, smell the ozone. And for people who's shocked by that did happen, they didn't go in electrical engineering. They were a fear of electricity. And it's a healthy fear. Electrical things can hurt people. And at this point, I'd like to maybe turn over to Marco and talk about some of these faults.
Thank you, Cliff. My name is Marco Cabibo. I consent to being recorded. Good morning, Mr. Registrar and committee members. I've been fortunate to work in electrical construction, engineering, design, some limited research, and education in the electrical industry for the last 30 years. And I look back and I think, how did that happen? And it was because I realized I was passionate about it. So in the next 5 to 7 minutes, I will be presenting in some simple manner some electrical theory and some safety considerations that surround the installation of battery energy storage systems. But I want to be clear that what I'm presenting really is about public safety. And in my bio, I didn't mention that I'm a father of 2 daughters who are now in their 20s, and they're getting ready to start their own lives. They're looking to buy homes. And honestly, as I raised my awareness about this topic, I was aghast to realize that untrained personnel are doing electrical installations. Now, maybe that seems naive on my part, having been part of the construction industry for 30 years. But that's because I've worked with C10 electrical contractors, helping them get through plan check, helping them complete successful projects. And I realize the effort that they have to go through. And I understand the training that they've gone through. And there's a reason that they California state licensed electricians receive 8,000 hours of education and experience before they get their license. That's because electrical installations are not simple. And maybe you've experienced this yourself. You've been in Home Depot in the electrical aisle, and you see a homeowner pick up electrical parts, and he assembles them as he's trying to figure out how does he make the connections between the service and some other thing, like something simple like a light bulb or a switch. And although he may see how the pieces and parts go together, I'm very certain that he doesn't understand the risk that he's putting himself in, nor does he understand the risk that he's putting his family at. If he did fully understand that, I doubt that he would enter into that effort. So some of the images I'm going to show you today, while graphic, do not show injured people, mostly injured property. But again, I want to be clear, this is about public safety. And I'll remind you that you may have friends and family who will be buying homes and then contracting someone to install a solar system or a battery energy storage system. Wouldn't you want them to have the training and experience necessary to fully understand how they're interconnecting this system to the home to prevent catastrophe? Again, parts and pieces may go together very easily, but understanding the risk and the technical complexity of an electrical system is not a simple assessment. So let's take a look. I want to give credit to Mike Holt for this simple illustration, help the committee members maybe visualize a simple system. This happens to be of a photovoltaic array, an inverter, and the point of it is to show there's an interconnection here. That is a circuit breaker in a residential panel. When we're talking about installing an energy storage system to an existing electrical system, there has to be a connection point, and that connection point is typically a circuit breaker. So now that you have an image in your mind's eye. The electrical code is pretty clear about the requirements. And although I can read the electrical code, it is not an installation manual. It took hundreds of thousands of hours and many experts to develop the electrical code. Yet it is not an installation manual, and even states as much. Although we can take a cookbook and assemble the ingredients and produce a cake and then eat that cake, we may or may not enjoy the cake. But hopefully nobody dies. If we take the electrical code and we take the parts and pieces and assemble them and attempt to meet the requirements of the electrical code, we may or may not get a functioning system. At best, the system functions. At worst, some installation practice, which I remind you has been taught to state-certified electricians through their 8,000 hours of training and instruction. They have learned the techniques to install these systems. So your attention is drawn to this. This is a representation of a typical electrical panel in some older homes. 100 amps is very common. And although they can read the requirement that the electrical code says they need to assess the system, and the bus has to be of a certain size based on the connected load. I've done a simple calculation there. We're looking at a 100 amp panel. And if I may, state that one typical type of battery energy storage system could be 7 kW. They're going to attach it to the panel. That represents 36% of that panel's capacity. Now, if this is an older home, likely over the years, they may have added air conditioning. They may have added a spa with electrical resistance heating. They may have added other lights. They may have expanded the building. At that point, does the homeowner or an unqualified person really understand how much is already connected to that electrical panel? And then they're going to add more than 1/3 additional interconnection to that panel? I would suggest that they don't fully understand it. And this is an image, this is a slide showing a description. I would like to explain what a high resistance fault is. As an engineer, although I sat in a class and I understood it, it took many years of experiencing the damage caused by these in the field for me to fully appreciate what is happening with a high resistance fault. And a qualified electrical worker would understand the importance of properly installing equipment to avoid this. If they don't fully understand the electrical theory, mechanical techniques to install the electrical equipment properly, things like high resistance shorts and arcing faults could happen. Even if they did understand how to install the equipment they're going to install, once they connect to an existing system, they have to understand that now they're essentially taking responsibility for how their equipment operates with the whole system. And if they haven't had the requisite training, likely they will not understand that. So we talked, Cliff mentioned circuit breakers and how we all really expect a circuit breaker to do its job, and that's to interrupt power during a fault condition. But here is a diagram that explains. that a 20 amp circuit breaker is rated to deliver power at 80% of its rating continuously, forever, until, well, so 16 amps. But if there is a fault to ground, and it doesn't represent 0 ohms, and there's some resistance to it, that fault looks like a load to the circuit breaker. And if it doesn't exceed the circuit breaker's trip rating, it will not clear. In this case, we could have a high resistance arcing fault that either occurs from improper installation of electrical circuits or not identifying poorly maintained existing electrical equipment, and that circuit breaker will continue to conduct up to its rating until something happens. And in the next couple slides, you'll see the results of arcing faults, where the breaker failed to clear because the breaker thinks that it's just conducting power up to its rated capacity. And I think that most people may have experienced this in their homes. They've seen these images, burnt electrical receptacles. And again, this is an example of a condition that can occur if a worker is not fully qualified to install electrical equipment properly. And I want to reiterate, state certified electricians receive 8,000 hours of training and education on how to install these parts. Just because I can go into the aisle at Home Depot and I understand how to apply a wire to a terminal, that doesn't mean that I fully understand the risks involved.
I have a question. How many of those 8,000 hours are required to be on solar?
I can
By
defer
the
to our
state.
panel members, please. Actually, I'm not talking about solar, I'm talking about the interconnection to an existing electrical system. So I don't know that that's a relevant
How many
question.
hours are required for a C46 tradesperson? Is there any?
My question was rhetorical. There's no requirement for any of those 8,000 to be solar related.
Again,
But they're actually sitting in a classroom and working for 8,000 hours as opposed to somebody who literally could potentially have no skills whatsoever.
I don't know
under
that
a
the question was
C46.
relevant, because what I'm talking about is interconnection to an existing electrical system, so.
Yeah, I agree. I think the argument's on the AC side. No question what Mark is talking about.
Yeah,
I think so.
How is this different from ESS from PV? Are we talking about something specific to ESS that,
I think I stated that.
Calls this?
Interconnection to an existing electrical system.
how does
And
that differ from a PV interconnection? Because there's no question there that we can interconnect PV.
there is a lot of question. I thought you heard me say that I question and I'm horrified to find out that unqualified people do this. And I'm concerned for the safety of my family and all families that unqualified workers are doing electrical installations and they don't fully understand the installation requirement. That's the point of what I'm saying here.
So I just have a couple of points, and I really appreciate the slides that you showed up. This is Barry Cinnamon. Cliff and Marco, your qualifications as electrical engineers are very impressive. I'm just an old-fashioned licensed C10 and C46 contractor. Been doing this for a while. My question, if you could back up a few slides. Let's go to the first slide, please. Yep, but next one, please. So my question is, how many of these systems have you actually recently installed? Because the diagrams that I'm seeing up here are completely inconsistent with what I've been installing for the last 5 to 10 years and completely irrelevant to battery systems. So I'm asking about the installations. The current state of technology has we're not putting in a battery, we're putting in a battery system that's listened to US.
Barry,
UL
I think I
and
pointed
has-
out the reason for the slide was to show the circuit breaker interconnection point. Did you miss that part, Barry?
Oh, I didn't miss it, but I'm looking at this thing called a combiner.
Well,
and a
go ahead and throw
combiner
the slide
disconnect.
out.
Well,
The point
this
of it
is-
was to show the circuit breaker interconnection so that the committee
But-
could get an image in their mind's
But
eye.
we're talking about current technology. Mike Holt is very knowledgeable, but this is archaic.
Okay, I
And
get
let's
that.
talk about
I get that,
current
Barry.
technology.
So I can change the slide then, because the point really was about the circuit breaker interconnect. I hope I made my point clear about that. so-
Marco, how many more slides do you have? Just curious, to get through them, and then we
Just-
can take a break
sure,
and come
just
back
a-
for questions. That's what,
Probably 7, and they're just images. The last 2 are bullet points, so it'll be cool.
We
And
did have one
Marco,
more
just
presenter,
also,
too.
with regards to that slide, there's something called the 20% rule, which is something that every single permit that I've ever done for 20 years includes. So we're all very familiar, whether we're C10 or C46 licensees, as far as the importance of the 20% rule to prevent overloading a panel. It's just standard.
I'm glad to hear that, Barry. That makes me more comfortable. Thank you.
And Mark, I'd like to thank you for making the remark that, yes, when you're talking to the inverter, and if PV is connected to the inverter, that is a safety issue. And although you rest yourself being comfortable has been dealt with, I think it definitely needs to be revisited. And also, to answer your question, I don't think the Contractor Licensing Board would appreciate if Mark or I did installations. We do not hold licenses as a contractor. As engineers, we are not licensed to install.
Well, then I think it's important to note that they're not unqualified installers. They are qualified, maybe not to the same qualifications that you would your licensed electrician, but that doesn't mean they're unqualified.
And
Yeah,
Brad-
I'd be welcoming that, the listing of the qualifications, the apprenticeship programs, and the training that's given. Thank you.
So
Brad-
could we just allow the presenter to finish his presentation, and then we can have debate or discussion after that? I'd like to hear the complete presentation, if that would be possible, please.
Thank you, Christy.
Thank you.
This is an example of knob and tube wiring. A rat's nest of an electrical panel. So, how do we avoid high resistance arcing faults? And I would suggest that you avoid them by hiring California State certified electricians who receive 8,000 hours of technical electrical training and experience. I would suggest that you hire certified electricians who receive training on proper installation of electrical equipment. I want to emphasize that these electricians, state-certified electricians, must pass a state certification exam. And as a consumer, that makes me very comfortable. I would also say and remind that these state-certified electricians must complete 32 hours of continuing education every 3 years in order to maintain their license. As a consumer, that makes me feel very comfortable and confident in their abilities. How else do we avoid high resistance arcing faults and other misinstallations? We hire California state certified electricians who are qualified to assess the whole electrical system. Electricians, state electricians, qualified state certified electricians who are trained to perform the necessary calculations. And we hire individuals who through 8,000 hours of training have learned to take ownership of the whole system, not just a point of interconnection, but they understand the whole system. And we hire state-certified electricians who are cognizant, meaning aware of the lack of electrical equipment periodic maintenance that might be present in these existing older homes. Breaker exercising, breaker replacement after maximum cycles. They have been taught and trained to identify these. These are all contributors to misinstallations, to arcing faults, to fires, and to unsafe conditions for our loved ones. And that completes my presentation. Thank you.
before we get to questions, I'd like to take a 10-minute break.
We do have one more presenter, Dave.
Oh, can we do it after the break?
Sure.
Okay, are we ready to reconvene? Just a reminder, we are in the study phase. We really appreciate the presentation. We want to be respectful to the presenter and allow them to get through their presentation. And then we'll be happy to entertain any questions or comments. Eddie, who do you have next?
Comment, and then Tom Enslow would like to present on the threshold limits that we believe are appropriate.
Yes, Bernie Contlier from the LMCC. I just want to summarize the excellent presentations that the consulting engineers have made and emphasize a few key points. We've heard a lot about the so-called plug-and-play or allegedly plug-and-play equipment that is apparently safe. I've been in meetings where I've seen demonstrations of these storage units and the claims that they are 3 wires, that they're simple, they're easy, they're safe, and that they have a lot of built-in safeguards. I think this needs to be addressed, and it was addressed in a way, but I want to make it very clear that these systems are absolutely not plug-and-play. They are not safe. And the reason for that is the testimony that has been given by our engineers, and that is that once you take that appliance, no matter how safe it may be internally, and you connect it to a system, whether it's a home or anything else, you are connecting it to an electrical environment. And that electrical environment may be 50 years old, it may be 70 years old, it may be 20 years old, and it's going to be a combination of wiring, circuit breakers, other electrical components whose age may vary tremendously. They may have been worked on, they may have been done unpermitted work, they may be very old. All of those conditions in that system add up to a unique electrical system. Every home that is out there that is not brand new is a unique system with all those combinations. And when those combinations are stressed, as our engineers have pointed out, you can have a lot of problems. You can have arcing faults, you can have overheated wires, you can have fires, you can have electrical shock, you can unfortunately even have electrocution. So the claim of plug and play is blatantly misleading and untrue because it becomes part of the electrical system. To assess the quality and the safety and the character and the capacity of that electrical system is something that is essential. In the video that the C46 presented to the board, they had a gentleman from a company in Australia who said they can install this system, this battery system in 30 minutes. Well, what can you do in 30 minutes? You can hook up those 3 wires, but you cannot do a proper site assessment and load calculation. You cannot inspect the wiring. You cannot inspect the breakers. You cannot properly assess all the aspects of that electrical system. And when you don't, you have problems. I'm going to submit for the record a number of photographs of electrical faults, the consequences of electrical faults, which include overheated components, overheated wiring, and breakers that have caught on fire. And I'm also going to submit for the record a number of copies of one of the formulas that is required for a qualified individual to assess that electrical system that battery energy storage has now become part of. This one formula is just for the calculation of wire sizing, the proper calculation of wire sizing. To do a proper site assessment and load calculation, you have to know about 6 times this amount of math. This does not come from somebody who's been installing solar systems who has no record of training and certification with the state of California. This comes from someone who has that 8,000 hours of experience, who has addressed all these myriad, thousands and thousands of different combinations of old wiring, old components, improper installation in the past, and all the things that have to be addressed to make that system safe. And that is serious business because that is what protects the public. And no matter what training the C46 industry claims that their people have, there is no proof. There is no state certification. There's no way for the market to identify that they have a certain level of training, whereas with a state-certified general electrician, that certification is evident. It can be checked with the state, and we know that that person is qualified. So I want to submit these as evidence. Thank you.
Do you have extra copies to share with the rest of the room?
This is Bernadette. I also have a question for you, Bernie. How many of those photos that you're submitting for the record involve a energy storage system?
Actually, you know, I think that this is indicative of missing the point, Bernadette. It doesn't matter if it's a solar system. It doesn't matter if it's a battery energy storage system. What matters, and I'll let our engineers speak to this, and our solar contractors, is what you're doing to the system. Are you adding load to the system? Are you adding stress to the system? What is it electrically that you're doing to that system to cause it? And I'll let the, would you like to speak to that, Matt?
How
But
about
it
just
sounds like-
answer the question?
Yeah, it sounds like the answer is no. None of the photos involve an energy storage system.
That is not
What
the
difference
point.
does it make?
It's not the point.
It's not the question if it's the point.
The point
What difference
is
does
the
it make?
loads that you're adding to the system, and certainly battery energy storage systems do add loads and stress to a system. And I'll let the engineers speak to that. Who would
But-
like to talk?
Just so we're clear, are you refusing to answer the question?
No, I answered the question.
Okay, so let me repeat, because I didn't hear an answer. Do any of the pictures you show depict a condition associated with an energy storage system?
An energy storage system, once again, the engineers will answer the question. I'm not an engineer. They will answer that question.
Well, they're your pictures, so I would assume that you know
No.
what your pictures depict.
No, they're not my pictures. They're pictures that represent safety issues that we all understand come with additional load and additional stress on a system, which many components can add to that system, including battery energy storage systems.
When you're talking about a plug-and-play system, you're talking about plugging into the battery itself. What's on the other end of those wires is what Bernie's talking about.
I think our system is our question is very simple. You've introduced into evidence a series of photographs.
Yes.
We have asked you, do any of those photographs depict a situation associated with an energy storage system?
Yes,
They may or they may not.
But can you tell us right now that any of those do?
Do we need to right
Potentially.
now?
Okay, so you're refusing. Do
They
any
may
of
or
them-
they may not.
Are any of them associated?
They may
with-
or they may not.
I have a second question. Do any of those pictures, are they associated with those physical pictures with a photovoltaic system at all?
Are the graphs of the work that you've shown related to projects that have those types of devices on them?
We don't know what the devices are because you didn't show us the picture, but
Yeah, you are.
I think you've
What I-
answered my
no,
question
I
by
haven't.
your refusal
No.
to answer.
No, I'm not refusing to answer. Those devices are on the projects of the graphs that Bernadette showed. It's all the same. It's all electrical work. And just because the lights come on doesn't mean an electrician did it.
But I think the question here is whether or not we are qualified to do it and whether we do good work. So the question we're asking was, do you have evidence that C46s are doing bad work, or are you just showing examples of bad work? Because if you're showing that example, that was an electrical outlet. That wasn't installed by a C46.
Now, what we are demonstrating, to be clear, is not the point of who installed it, or whether it was a C46 or a C10, or whether it was battery energy storage, or whether it was solar. That is not the point of those photographs. The point of those photographs is that any time you add an appliance, an electrical device, into a system, the condition of the whole system is now at risk. That is the point. And the point is particularly relevant because we have heard in the last few years dozens and dozens of claims, and we've seen Mr. Cinnamon bring in an LG dummy, a wall unit, and claim that it was simple and easy and safe because it was 3 wires and anybody could put it in, and that influences the staff and the board's conception of what is safe.
Likewise,
And the
what you
point-
just
Hold on, I'm
entered
not
into
finished.
evidence
I'm not
was a
finished,
stack
sir.
of pictures
Sir,
that
I am
depict
not
a
finished.
C10
I
can
am
make
not
mistakes too.
finished. You can speak when I'm finished. The point is that when you install any appliance to an existing electrical system, whether it's battery energy storage or anything else, you put stresses on that system. And it's those stresses that you have to understand can affect the wiring, the circuit breakers, and all other components of that system. That is the point. And when you suggest that something is plug and play and it's going to be safe, you are completely ignoring the condition of, the construction of, and all the combination of those electrical components which may or may not be safe. And unless you are a qualified electrician who has had the experience to do a proper site assessment and load calculation of everything in that system, you cannot claim that that installation is safe. That is the point.
Mr. Rejdar.
Yeah, I think, well, for putting it in as evidence, we're going to take it for what it is, okay? He's not stated this is related directly to a battery energy storage system. So do you have something?
Just a point of order. I have several questions and responses to the testimony. So I don't know if this is the right time, or they said they had one more speaker over here, but we'd like to make note that we want to have questions and responses.
Yeah, let's finish the presentations if we could. So I know we have something now on our whiteboard, which looks pretty interesting. But Eddie, do you have another presenter?
Yes, Tom Enslow is going to present regarding, was that Tom?
Yeah, I think you guys need to turn off your mics.
Oh. Regarding the thresholds that would be proper to delineate when you need to use a qualified individual to make the installations.
Good morning, Tom Enslow. I'm going to do you all a favor and bring this back to why we're actually here, which was, the staff was directed to identify recommendations on what restrictions should be placed on C46 installation of energy efficiency, energy storage systems based on size, complexity, voltage, and risk. And I've provided staff a number of handouts, and I have extra copies I can provide to Kelsey afterwards. Which summarize, what's in the record, both technically and also some of the economic arguments that relate to this. Over the last couple of years, you've received a number of letters and reports that talk about the dangers associated with energy storage systems, including explosion and gases and exposure to hazardous chemicals, a lot of dangers that are very different from what you see in a solar system. And more kind of germane to setting a threshold, there's evidence that any of these systems are electrical and has been testified they're dangerous. But as they get bigger, that danger expands in scope. A 20 kilowatt energy storage system, 20 kilowatt hour energy storage system has the same amount of energy as, I believe it was 72 sticks of dynamite. So, if you have a 1 kilowatt hour storage system, that's a lot less energy storage and explosion scope risk than a larger system. And if you look at the document I provided you, technical arguments for size threshold, on the page 4, you'll see a graph that shows there's a direct correlation between the energy storage capacity and the intensity of a fire that will occur if there is a problem. And so when you have all these issues that were talked about that happen with all electrical components and even with smaller energy storage systems, and it starts a fire, and then you have a large capacity of storage, the explosion risk and the fire risk goes up exponentially. So this is why in the codes, there are all sorts of size thresholds that have been set above which the national and state code body setting authorities have required more installation standards, more fire and life safety requirements, stricter permitting and sprinkler requirements, all sorts of additional requirements because these are less safe. And why this is important to you, it means you don't have to reinvent the wheel. We already have standards that have been set by the national and state code and standard setting bodies. And I've provided you some excerpts from NFPA 8855, which is the standard for installation of stationary energy storage systems that was just published this past month, and also some excerpts from the California Fire Code. And both of those set standards based on size. And so I just kind of want to go over kind of some of the standards that are there in the codes. Really, the first standard that you see is actually in the electrical code, which sets a threshold of 50 volts or 60 volts, which is above that, then you have to comply with it's a system that's now regulated by the California Energy Code. And that's, when you talk about the historic use, when we used to use 12-volt car batteries for energy storage, those still wouldn't be covered by the Energy Code because they're not, they're not big enough. So we have a 50-volt, 60-volt threshold that's used by the electrical code. The fire code and the NFPA 855 set thresholds based on type and capacity. So for lead acid batteries and nickel cadmium batteries, it's a 70 kilowatt hour threshold. But for lithium batteries and sodium batteries, it's 10 kilowatt hour threshold. And then there's a catch-all threshold for 10 kilowatt for all other battery technologies, so for new technologies of 10 kilowatt hours. So you have a suite of thresholds set in the code, at which point you have to have additional requirements as far as flame arresting safety camps, thermal runaway management, smoke detection, gas detection and ventilation, spill control, seismic protection, failure modes and effects analysis. There's permitting requirements by the fire code when you get to these sizes, which requires specific details on location, fire-resistant assemblies, quantities and types. There's all sorts of standards that start to kick in when you hit above generally a 20 kilowatt hour threshold. So that's basically the threshold at which, yes, these are all dangerous, but the size of the bomb, basically the size of the gas tank is so big at this point that this is the threshold. We need more qualified people. We have to do stricter standards. There's stricter inspection requirements, and that's a standard that the board could use, and it's supported in the record, and they're not making it up. It was based on the national and state proposals. There's also another standard you could consider, which in the NFPA 855 now sets a 1 kilowatt hour threshold for 1 or 2 residential dwellings, in which there's specific requirements that are, there are additional installation requirements at that threshold, and then there's more requirements once you get above the higher thresholds. So, and I lay this all out here, but this is for the staff to review to see what has the industry as a whole, what has the code setting and standard industry been using to determine at what point are we really concerned about safety, and do these become more dangerous systems? And this is important for a couple of reasons. I mean, I think it's good to step back and remember the classification here for C46 is for solar installation of solar systems, solar PV. It's not a classification for energy storage. The only way they get to do energy storage is because for a specialty classification, you can do incidental and supplemental work. And the question is, historically these have been smaller systems that have been incidental and supplemental, but at a certain size, these become very separate systems with more complex installation requirements, more risk, and they should no longer be considered a incidental and supplemental system. They need to be considered a separate system. That's really what the board has been tasking you with and deciding is that, wait a second, at a certain point, these can't be considered to be just part of the C46, normal work. And the other point I want to talk about is kind of the economic arguments that have been thrown out, and how the idea that this would disrupt the market, because we disagree with this. When we look at the actual market, we took a look at two things. We looked, first of all, we did a study of what is the residential market for home energy storage system. We identified 85 home energy storage systems that are on the market, and we provided some footnotes to that. And of those 85, all but 4 are under 20 kilowatt hours, and all but and most of them are under 10 kilowatt hours as well. And this is the handout I had that says economic arguments for the 10 kilowatt, 20 kilowatt hour threshold. So you can see, right now, the vast majority of these systems for residential that are on the market wouldn't be affected by a 20 kilowatt hour threshold. In addition, if you look at what's actually being installed, we took a look at the CPUC data for their SGIP program and the rebates they've been given from 2017 to 2019 for residential energy storage systems. There were 14,000 rebates given over the last 2 years for residential energy storage systems. 80% of them were under 20 kilowatt hours. And so, you're talking about if you set a 20 kilowatt hour threshold, 80% of the market is not going to be affected at all. The C46 contractors can still do business as usual. For that 20%, that's the higher risk, higher capacity, higher explosion scope. For those, there is the idea that this would disrupt the market. Again, doesn't stand up when you look at the facts. The fact is that of the 1,300 current C46 contractors, 753 of them already hold other contractor licenses that would allow them to do installations above 20 kilowatt hours and would allow them to do standalone energy storage systems. That represents 57% of all C46 contractors. So just in the C46 contractor world alone, there wouldn't be any disruption. Most of the vast majority of their contractors, and I assume when they're talking about these big 1 megawatt systems, I would hope that the contractors that are installing these are the ones that have a C10 and a C46 contractor license. But this would, right now, you really wouldn't disrupt the market. The 57% of the C46 contractors can already do the work under their other licenses. And the ones that can't, there's 80% of the residential market that they can still do. And in addition, there's 78,000 C10 contractors that do this work. And they can do this work as well. So when you're talking about limiting this to a threshold such as that the code bodies already have set at 20 kilowatt hours, it really would not impact the market in the way that's being represented here. Most of the work on residential, over 80% of that work could still be done business as usual. And we're talking about the bigger systems where when you have these dangers and you have poor installation, what's the scope? It's if you light a match to a 5-gallon drum of 5-gallon gasoline container or a 1,000-gallon gasoline container, there's a big difference in the scope of what's going to happen there. And so that is why we have a storage capacity threshold in the code standards, why it makes sense for the CSLB to set a storage capacity threshold when determining whether or not you're going to consider an energy storage system just incidental and supplemental work, or it's a whole separate system, and it's just does not, it's beyond the scope of what this classification can do. So, thank you.
Mr. Register?
Yes.
If I may respond to several of the points in the testimony that we're hearing here for the first time. First off, let me sort of work backwards here. The 20 kilowatt threshold that exists in National Electric Code is residential, and there's a companion 600 kilowatt hour threshold for commercial. So if that needs to be made clear. 600 kilowatt hours, above 600 kilowatt hours commercial or 20 kilowatt hours residential, you need to be installed by a qualified person, not clearly defined in the National Electric Code. So there's that companion. The 60 volts he mentioned is 60 volts DC exposed terminals. So it's an important clarification that we need to make sure is out there.
That's not correct. It's 50 volts AC, 60 volts DC. In all, we're hearing here the basis very clearly for the proposal in saying that solar is equally implicated. And
the shortage of labor is a very real issue. I mean, it's a plain fact. Certified electricians don't want to be on the roof
Skilled labor, yes.
installing on solar panels. So to the extent that this proposal has spillover implications for who can be hired on a crew to install both solar and storage, there's no way we're anywhere close to having enough certified electricians to do all that work. And it's not the best use of that talented labor pool. There's a lot of electrical work to be done out there. Putting electricians on rooftops is not where they should be.
So are you saying that there's so much of this work that it's okay to give it to people that don't have certifications and don't have schooling and don't have licensing just because we need to get it done? Is that what you're saying?
The point made
That's kind of sounds like
over
what
and
you're saying.
over about an electrical connection that when
No, you didn't answer the
interconnect
question.
system-
It was kind of a yes or no
No,
question.
it's a no question.
So you're saying, no, don't put unskilled, untrained people on that work.
Well, you're assuming that they're unskilled and untrained,
that's not
notwithstanding the
accurate.
fact that they've been doing it for 40
Yeah,
years.
let me make
What-
that point. Let me make that point and address your question.
Not 40 years.
Um,
Have you ever interviewed somebody and worked beside them, Donald? Have you ever interviewed a
You wanna
skilled
ask either of us
tradesperson and
that
worked
question?
beside them? I'm not talking to you, Mark, I'm talking to Donald. Have you ever interviewed a tradesperson and worked beside them based on their skill set in this environment?
No, I'm a lawyer. I don't go up on the roof.
Right, so you don't know what it's like to work next to a skilled tradesperson and know and be able to identify quickly, without question, what they do and what they do not know.
So actually, if I may, I understand that you all are all extremely concerned because you don't believe anybody other than a certified electrician is properly skilled to do electrical work. Is that a fair statement?
That's a fair statement.
Okay, so I wonder what your response is to the following. Why is it then that certified electricians are required to do any electrical work for a C10 with one big, huge, gaping exception? A certified electrician is not required to do any of the high voltage work for transmission or distribution systems that are owned by a utility. Tell me, why is it okay, and as in Labor Code section 108.2A3, why is it okay for utility workers who work on high voltage, which you've told us is the most dangerous aspect of all of this, transmission and distribution lines, why is it unnecessary for them to use a skilled workforce, but it is essential for them to use certified electricians to do rooftop solar and battery storage systems? I'd like to understand that distinction.